space lanes of laser beams emitting conscious signals throughout the galaxy, and unfortunately, we as humans are not smart enough to understand it. Andromeda, our galactic neighbor. We can observe it in our sky without a telescope, which is interesting. However, things have gone from interesting to disturbing and alarming. Michio Kaku has revealed that the James Webb telescope has picked up disturbing signals coming from Andromeda, and these signals turn out to be much more dangerous than we could have ever anticipated. Join us on this journey to discover the truth behind these alarming signals and how the future could be far more terrifying than we ever imagined. Andromeda is a cosmic giant with fascinating characteristics that distinguish it in the vast universe. Also known as Messier 31 or M31, it's the largest galaxy in our region, with an impressive diameter of approximately 220,000 light-years, a true celestial wonder in terms of its cosmic magnitude. Although the Andromeda Galaxy lies at a considerable distance from Earth, approximately 2.5 million light-years away, its position in the cosmos places it beyond the limits of our galactic neighborhood. Although its size may be frightening, it's also fascinating to observe its structure. Andromeda shares a similar structural design to our own Milky Way, with the bare spiral configuration. This feature is highlighted by a central bulge of matter, surrounded by a flat disk containing stars, gas, and cosmic dust. Its symmetrical structure shows the impressive complexity of this galaxy. In terms of its stellar population, Andromeda is home to an extraordinary 1 trillion stars, far exceeding the number of stars in our Milky Way galaxy, which has about 250 billion stars. This explains why it's so visible from Earth, since its brightness is certainly greater. However, the grandeur and luminosity of a galaxy are not the only intriguing characteristics it possesses. Open space hides many secrets, and each galaxy has different and surprising peculiarities. At the core of the Andromeda Galaxy, a concentrated bulge of matter stands out in the spiral structure of the galaxy, illuminating a distinctive appearance. This central bulge is believed to contain a high concentration of stars, influenced by the gravitational pull of the galaxy itself. Given that the galaxy has an abundance of stars, it's not surprising that a percentage of them cluster together to form this bulge. In addition, there's more than 400 globular clusters scattered throughout the Andromeda Galaxy, which are spherical collections of stars bound together by gravity. So, despite being an immense galactic beast, the Andromeda Galaxy is not alone in space. In fact, it has an entourage of at least 14 known satellite galaxies orbiting around it, forming a fascinating cosmic family. The interactions between the main galaxy and its satellites play an important role in the formation of their respective structures and evolution, contributing to the rich diversity of cosmic phenomena in the Andromeda system. The presence of a ring of dwarf galaxies surrounding Andromeda has been discovered. These dwarf galaxies are relatively small and faint compared to Andromeda and the Milky Way. The finding of this ring suggests a gravitational interaction between Andromeda and these dwarf galaxies, indicating that the dwarf galaxies are under the gravitational influence of Andromeda, probably due to the immense gravitational force of this galaxy. The ring of dwarf galaxies is the subject of active research, as the exact nature of this interaction and the mechanisms that led to the formation of this ring are still under study and analysis by scientists. To advance on our understanding of galaxies, dark energy, and star formation, including the Andromeda Galaxy, two powerful instruments are being used: the James Webb and the Dark Energy Spectroscopic Instrument. These instruments play a crucial role in the study and analysis of cosmic phenomena, allowing the mysteries surrounding the Andromeda Galaxy and its stellar environment to be investigated with greater detail and precision. The James Webb is considered the most powerful telescope ever built, and is designed primarily to observe the universe in the infrared spectrum of the electromagnetic spectrum. This feature allows it to study the first galaxies forming in the early universe by detecting the faint light emitted by these distant galaxies. James Webb's goal is to provide valuable insight into the formation and evolution of galaxies, including the Andromeda Galaxy. and its observations will contribute to our understanding of the processes that have shaped the universe over time. On the other hand, the Dark Energy Spectroscopic Instrument, or DESI, is an instrument specifically designed to study dark energy and galaxies. DESI uses optical spectroscopy, which consists of breaking down galaxy light into its different wavelengths to analyze the spectra of millions of galaxies. Through this massive spectroscopic study, astronomers can measure the distances to galaxies and obtain information about their properties, such as their chemical composition, formation history, and motion. DESI's analysis of distribution and motion of galaxies sheds light on the enigmatic nature of dark energy, a mysterious force that drives the accelerated expansion of the universe. In the specific context of the Andromeda Galaxy, DESI observations have provided fascinating insight into the migratory history of stars within it. By analyzing the spectra of individual stars, DESI can reveal information about their chemical composition and origins. This allows astronomers to trace the history of star formation and follow the movement of stars within Andromeda. By learning more about stellar immigration patterns, scientists gain a better understanding of the formation and evolution of the galaxy, as well as its interactions with neighboring galaxies. In addition, recent studies have provided compelling evidence for the existence of a stellar halo in the Andromeda Galaxy that bears similarities to that of our own Milky Way. This discovery has illuminated the dynamic nature of galaxies and the intricate interactions between them. Observations and simulations suggest that a significant number of stars found in the outer regions of Andromeda's stellar halo have migrated from small satellite galaxies that were gravitationally captured by Andromeda. Over time, several dwarf galaxies merged with the Andromeda Galaxy, taking their stellar populations with them. This process of galactic cannibalism is known as galactic accretion or merger. Galactic mergers are believed to be common in the universe and shape the structures and characteristics of galaxies, including Andromeda. The presence of stars from other galaxies, resulting from interactions and mergers with smaller companion galaxies, helps researchers understand the kinematics and distribution of stars in the stellar halos of galaxies, such as Andromeda and the Milky Way. By studying the populations of stars in these stellar halos, astronomers can trace the history of galactic mergers and interactions that have shaped these galaxies over billions of years. The stellar halo contains stars that have been absorbed by smaller satellite galaxies or star clusters, and their properties can provide valuable information about the history of galaxy merger and assembly. This galaxy merger process has been a key factor in the evolution and formation of galaxies, such as Andromeda, and has contributed to the diversity of features and structures observed in them. Through detailed observations and computer simulations, scientists can analyze the chemical composition, age, and motion of the stars that form the stellar halos. These data allow them to reconstruct the time sequence of galactic mergers, identify the progenitor galaxies that will contribute to the stellar populations, and understand the physical processes involved in such mergers. This approach is of utmost importance because if this massive galaxy will ever come into contact with our own, it will be crucial to be prepared with all available knowledge. So what do you think? Let us know in the comments box. If you enjoyed the video, hit the like button, share it to reach more people, and subscribe to the channel so you don't miss out on more content like this.